I'm glad you guys came back today. Yesterday we built cars out of water bottles, straws, and the water bottle lids. So this is what they should look like. Today we're going to power these cars. What do you think we could power the cars with?
Pushing it?
You think we're just going to push it? Well, we're actually going to power it by this. It's really cool. And it's sometimes hard to do because the tape gets kind of stuck to you. But it usually works out pretty well. Isn't that pretty cool? So, we're going to power these by this balloon. But that's not all we're going to do. We actually have to talk about some scientific things. We're going to talk about the speed of this. And for speed, the formula of speed is distance over time. Have you ever heard or do you know anything that has a speed to it?
A car?
Yes, a car. Do you know what, how you measure a car?
Miles per hour.
Yes, it is miles per hour. So would it be realistic to measure this for miles per hour?
No.
Why not?
Because the table's not a mile.
Right, the table's not a mile, but if I blew up this balloon, could this go 1 mile from this balloon, do you think?
Maybe.
Maybe. Do you think it could go for 1 hour? You saw me blow it up. How long was that? Was that an hour?
No.
So that wouldn't be realistic. So what are some other times that we could use?
Maybe feet per second?
Yes. So what we're going to do is we're going to measure out 6 feet. So let's see. 1, 2, 3, 4, 5, 6. Ooh, our measurement was just barely off. So, when you calculate your time, it's just going to have 6 feet at the top, and then you just have to time how long it takes to get there. Now we're going to do this a few different times because we want to get the average speed. Do you remember what the average is? So it's where if you had the number 5 and 7, the average would be 6. You add it up and then you divide by however many you have. Does that make sense?
Yeah.
Okay. So you're going to do that 2 times with a red balloon, and then you're going to do it 2 times with this big blue balloon. Which one do you think will go farther?
The big.
You think the big balloon? Why do you think that?
Because it holds more air.
Okay, well we're going to see if that prediction is right. So when you make this little setup right here, it's kind of tricky, but it's pretty easy. You can experiment if you want in your groups, but I found it was best for me when I had 3 straws. And so you'll take the 3 straws, and then you'll take your balloon, and you'll put it inside and all the way to where your straws bend, okay? And then you'll take some tape and you'll wrap it around the middle, and then you'll take more tape and you'll wrap it on the sides of the tape, and then you'll wrap it in the middle again so it's nice and secure. And then you'll just tape it so the open part where the coin is will come up here. And do you have any idea why I had to put this coin here? Well, the balloons got so heavy at some point that it was going like this and it wouldn't work because the balloon just tipped it over. So with the little coin there, it was perfect. So you want to construct that. And you put it in. Can you get it?
Yeah.
You can rip the tape for you. Your partners must be missing out on the fun because they didn't show up today, right?
So it goes around like this.
Yep. Far enough? in the straw, part in the balloon. And now this is going to be all on the balloon. But to overlap, Do you know why we're putting this tape on here? This one goes around the straw.
Maybe to keep the straws in.
Yep, it's also to keep the air in, because if you don't have it taped up nice and tight, the air comes out. So every time you blow in, the air just comes out, and it's really annoying because you have to blow more air in, and then you get frustrated. So just to make sure you're good, you want to tape that in the middle again. All right, and then I'm going to tape it onto your vehicle. I want to say something about science. If it doesn't work out the first time, you try again. Because when I first did this, it didn't work the first 2 or 3 times. That was because the wheels weren't spinning, and then I told you about the balloon tipping it. So your first attempt, it might not work out, but it will work out because you'll keep trying and changing one thing at a time. So you can come over and you can measure it. Can you do the stopwatch? And I'll time it. Okay. It's also helped sometimes. I had to hold it up here too while I was blowing, and that kind of helped it. Ready, set, go. All right, you have 2 seconds there. I just rounded it to 2. It's actually 1.9, so we'll write 1.9 down. It's kind of hard, isn't it? Ready, set, go. This time it really was 2 seconds. So if you had 1.9 and 2 seconds, what would be the average time? What's in between 1.9, 1.90, and 2.00?
Maybe 1.5.
Yes, 1.95. So if we're going distance over time, the distance we have is 6 feet over what?
1.5.
Yep, so for this balloon, we have 6 feet over 1.95. Now we're going to work on the big balloon. This one, you said it would go faster. So we'll see if your prediction is right. Don't worry, I'm not cutting your straw. I'm just cutting the tape because it's kind of hard to get to. Especially if you do a good job taping. It should be really hard to get to. So how fast do you think it's going to go? Reach the spot?
1 second.
You think 1 second? Why do you think 1 second?
Because the air is going to come out faster.
Because the air is going to come out faster. That's a whole second faster, basically, than the other one.
Mm-hmm.
So how is the air going to come out faster in that one than in the red one? What do you think?
Maybe because all of the air in it is just going to come out faster.
Okay. Do you think the lip in the balloon, so this part, do you think that is bigger or smaller in the bigger balloon?
Bigger.
You think it's bigger? So you think maybe that could have something to do with it too?
Mm-hmm.
Okay. All right. You know what to do now. Now since the balloon's going to be heavier, do you think you should put the straw more this way or this way?
This.
Okay, so here's this. I don't know if this is going to work, like I said. Sometimes in science you just have to try it out and hope for the best. I'm gonna put the timer on. When I did this, it took forever to blow up the balloon. Think it's gonna go if it's that big?
Yes.
Okay, on your mark, get set, go. Oh no! So what are we gonna do? Are we gonna give up? Or are we gonna try again?
Try again.
Uh-huh. So there, the wheels actually might not have been straight. So make sure when you set it down that the wheels are straight. Ready? On your mark, get set, go. Okay, that one was 2.5 seconds. So let's see if we do it one more time and see if the average is less. Mark, get set, go. Alright, that one was 2.2 seconds. So what would the average be from 2.2 to 2.5? I'm going to take a minute to think about it.
Maybe 2.3.5?
Yes, 2.35. So the first one was 6 feet over 1.95. And the second one was 6 feet over 2.35. So which one went faster?
The first one.
Yep, the first one went a lot faster, didn't it?
Mm-hmm.
So what could we think? Why was our prediction wrong? That this one would go faster than this one. What do you think?
Maybe because this one's smaller, it would let out air faster.
That could be a great possibility. I think that's probably right. So, today we learned about speed, right? So can you tell me something you learned?
That maybe smaller things will go faster than bigger objects.
Mm-hmm. And what was the formula for speed? Speed was the what over what?
Distance over time.
Distance over time. Did you have fun with this project?
Mm-hmm.
Should we do more projects like this?
Mm-hmm.
I think so too.